At this point, we are familiar with the pi type and how it allows us to construct dependent functions, for which the output type depends on the input term. But to continue on our journey, we need to take a look at another very special type, one that's related to the pi type, but rather than generalizing functions, this type generalizes pairs. We call it the sigma type. Let's see how it works. Suppose we had a type A, and suppose we had a type family F that maps every term in A to a type in some universe. We can then use the type family F to construct a sigma type. The inhabitants of this sigma type are pairs. Suppose we had such a pair inhabiting this sigma type. The first term in the pair would be a term in A. The second term in the pair would be a term in the type that F sends the first term in the pair to. In this case, Z is a term in A and W is a term in FZ. In other words, to construct a term in this sigma type, we simply need a term in A and we need a term in F of that term. We call these pairs dependent pairs. But why do we say that the sigma type generalizes the notion of pairs? Well, suppose the type of the second term in the pair were not dependent on the first term in the pair. To do that, we simply consider the case where F maps every term in A to the same type. Let's call that type B. Note that we can write the type family that always maps to B simply as B. In that case, a term inhabiting the sigma type would simply be a pair whose first term is a term in A and whose second term is a term in B. And if this seems familiar, that's because this is the very definition of a product type. Thanks for watching.